Okay, this is part 2. Now part 2, we still will carry on with the part B. After we show the AD theta is given to be this, we need to find the value of theta for which A is a stationary value, and we got to find this corresponding stationary value of A. Now, first and foremost, we know that for stationary value of A, okay, so for stationary value of A, okay, dA d theta must be equals to 0. Okay, now, so we know from your part B, we have this, and if you divide 200 by both sides, we're going to have this. Now, if I let A equal to cosine theta, I will have this quadratic function, this quadratic equation, and by checking the discriminant, I know that the discriminant will be a 41. Okay, and I know that since this cannot be square root, this quadratic equation cannot be factorized. So I find cosine theta to be this formula, minus b plus minus discriminant over 2a. Since we already found the discriminant to be 41, we just insert here. And we got two values of cosine theta. Okay. Now this second value here must be rejected because cosine theta is outside the range of -1 to 1. Okay, so we're only looking at this cosine theta equal to 0.42539, and if you take the inverse cosine, okay, you're going to get 1.1314. Okay, and if you were to approximate to 3SF, we're going to get 1.13 radian. Okay, so what will be the stationary value of A? Now, since we know that A is given to be this, okay, we are going to substitute 1.1314 radian into the formula. Okay, so we are going to get A equals to, okay, the formula is here. Okay, I'm just going to move this in front. Okay, we did get A equals to 1.13, right? 200 sine, can I just try again? 1.1314. 1.1314. Okay, maybe I put a bracket here. And then this will be 3 plus 2 cosine 1.1314. Okay, now when I evaluate this, I make sure that my setup is radian because the angle is given in radian. Okay, so this will be 200 times sine of 1.1314, close bracket again, open bracket, 3 plus 2 cosine 1.1314, close bracket, okay, and close bracket again. Now this is going to be the answer. Okay, 696.998. Okay, now can I just check? Okay, so to 3 significant figure, we are going to get 695 cm square. Okay, now this is not all. Now in part C, can I just show you the question? Determine whether this value of theta makes A a minimum or maximum. Okay, now, okay, we already found that theta is going to be 1.13. This is the stationary value of theta. Okay, now this is your dA d theta. I have to choose between either to use the first or the second derivative test. What do you think I would choose? Yes, I prefer to use the first derivative test because if I were to differentiate this again, I will have to it's quite a little bit cumbersome. Okay, so I prefer to use the first derivative test. Remember, in the first derivative test, you need to draw a table something like this, where this is going to be theta, this is dA d theta, okay, and this is going to be the shape of the tangent. Okay, so this is 1.13. Now I need to choose two values, side to the left and to the right respectively. I choose 1.11 maybe and 1.15. Okay, I know this is going to be 0. Okay, now let me just share with you what am I going to do. Again, please check your setup, make sure you put it to radian. Okay, now 200 is just a constant, so I need to actually work out 4 cosine squared theta plus 3 cosine theta minus 2, evaluated at 1.11 and 1.15 radian. Okay, so let me just share with you how am I supposed to do this, especially how to go input cosine squared theta here. So this is 4 cosine 1.11. Be very careful. Before I do that, right, please take note, this is 4, I use a bracket first, cosine 1.11. Okay, this one I need to square. Am I right? So I'm going to put another bracket here and I'm going to square. Okay, so I'm going to get 4 cosine 1.11 square. Okay, that's what you do here. You have to be very careful here. Then 3 times of cosine 1.11, okay, minus 2. Now this value is going to be a positive, so I'm going to write plus here. Okay, I'm going to do likewise for 1.15. Okay, so again 4 open bracket cosine 1.15 close bracket again square plus 3 cosine 1.15 close bracket minus 2. I'm getting a negative value, so this is negative. Okay, so this is going to be positive, this is 0 and this is negative. So to answer the question, right, okay, whether this value of theta makes A a maximum minimum, so I'm going to conclude, okay, at theta equals to 1.13 radian, which is stationary, okay, A is maximized. Okay, now if you to look at the diagram one more time, okay, in other words, right, if this value of theta is going to be 1.13, okay, the area of the parallelogram will be maximized. In other words, this is going to be the maximum value of the area of the parallelogram. Thank you very much.